Welcome to on-demand training for FlowCam 8000. In this video, we will demonstrate how to visualize data from your flow imaging microscopy runs in the data display area of the VisualSpreadsheet main window. We will start by showing you an example data display layout and then show you how you can make specific particle analysis selections from the Preferences and Graphs menus. We will then show you how you can custom organize the way your data appears in the data display window and how to save your custom data display layout. To open our example layout, we will go to Preferences, Layout, and choose Load. An open file window appears showing a list of saved layouts from which we can choose. For this demonstration, we will select the sample layout, and when we click Open, the data display window updates. Notice how the layout name appears in the configuration status bar. From here, we can see that the previously selected particle properties and corresponding statistical calculations and graphing options include the metadata statistics of counts and particles per mil, the physical particle property statistics of diameter ABD, or area base diameter, mean and standard deviation, as well as edge gradient mean and standard deviation. We also see that statistics will be calculated using the particle property filters for edge gradient and diameter ESD, or estimated spherical diameter. The data in this filter statistics table will represent properties only for particles that fall within the limits of each of the listed filters. For example, in the EG 150 to 255 row of this table, the count percentage, particles per mil, and cumulative particles per mil values will only be shown for particles that have edge gradient values between 150 and 255. In the Context Summary tab, sample settings and run details can be conveniently referenced alongside the calculated and graphical data. Two types of graphs are included in this example data display: the Capture X versus Capture Y scatter plot and the diameter ABD frequency histogram. We will now demonstrate how to make particle property, statistics, and filter selections for your particle imaging analysis. To start, go to the Preferences menu and choose Particle Properties. This will open the Particle Properties dialog that lists all the properties that VisualSpreadsheet can evaluate in the particle imaging analysis and provide in the Data Summary, Data Display window, and in the exported data files. It is good practice to start your particle property selection by first clearing these three fields by double-clicking on the Check, Clear All tick boxes at the bottom of each column. Once all columns are clear, you can then use your scroll bar to advance to your desired particle properties. In this demonstration, one particle property we will evaluate is diameter ABD, or area base diameter. We will select the tick boxes in each column to ensure data related to this property are included in the summary, display, and exported files. The next particle property we will include in this demonstration is edge gradient. Note, by simply clicking on the particle property name, in this case edge gradient, the tick boxes in each column are automatically selected, making it easier to choose each column and ensuring data will be included in the summary, display, and exported files. Next, go to Preferences and choose Statistics. In the Statistics window, you can choose which metadata statistics to show, which particle property statistical calculations you would like applied, if you want to include cumulative statistics, and if you want context summary details in the data display. In the Metadata Statistics panel, you have the option to choose counts, efficiency, and times. The efficiency value here is the calculated efficiency for the run. This calculation factors the actual frame rate and actual sample volume that was imaged in the run. The times value is the actual time it took to complete the run. In this demonstration, we will choose just counts. In the Particle Property Statistics panel, you can choose general statistic calculations such as arithmetic or harmonic mean values, minimum and maximum values, standard deviation, coefficient of variation, and total values, as well as percentile values for the selected particle properties. In this demonstration, we will select to have the mean and standard deviation values calculated for the diameter ABD and edge gradient particle properties that we just selected. The Cumulative Statistics panel gives you the option to have VisualSpreadsheet calculate the cumulative distribution of particles based on count or based on volume as measured by diameter ABD, area-based diameter, or diameter ESD, estimated spherical diameter, values. When selected, cumulative statistics data are presented in a table in the data display window showing how particle counts or volumes are distributed over a range of percentages. In this demonstration, we will not be applying cumulative statistics, so we will not click the tick box next to the cumulative statistics label. At the bottom of the statistics window, you will find the context summary label. Make sure to click the tick box here if you want to have context details about the run shown in the data display window. Note, selected data from the statistics window will only be shown in the data display window if the respective tick boxes for each panel are selected. When you click OK, you will now see tabs for the chosen statistics preferences in the data display window, including the metadata statistics, particle property statistics, and the list of context summary details. To include filters in your data analysis, go back to the Preferences menu and choose Filters. Like the Statistics window, make sure to click the Show Filter Statistics tick box to ensure the calculated values and filter statistics are shown in the data display window. The Calculated Values panel lists options for you to ask VisualSpreadsheet to calculate. In this example, we have opted to have count percentage, particles per mil, and cumulative particles per mil to be calculated for particles that fit the filter criteria. The filter criteria are defined in the Filters panel. To add filters to the filters list, click Find, and in the Select Filters window, use the search field to find the desired filter from the list of filters stored in the VisualSpreadsheet database. Once filters are selected, their names appear in the Filters panel window. If you would like to edit a filter, first click on the filter name and then select the Edit button. This opens a particle filter definition window where you can change the maximum and minimum values for that filter. If changes are made, click Save. Once the desired list of filters is loaded, you can choose Save Filter List by clicking on the Save Filter List button, which will give you the option to provide a unique name for the filter list. In this way, you can directly load the filter list from the database the next time you prepare a new run. When you click OK in the Filter Settings window, a new tab appears in the Data Display window for the filter statistics data. If you would like to add a new filter to the analysis, go to the Preferences menu and choose the Filters option to open the Filter Settings window. In the Filters panel, click the New button, and from the Particle Filter Definition window, choose an available property from the scrollable list by clicking on it, and then move it to the Value Settings window using the arrow buttons. With the new property in the Value Settings window, you can now input specific maximum and minimum values. If you click Save, this new filter will now be listed in the Filters panel window. For this demonstration, we are not adding any new filters. We will only be filtering the data based on edge gradient and diameter ESD values. Next, you can select how you want your particle imaging data to be visualized graphically. There are many options available to you here. We will just show a couple of graph options as an example. First, go to the Graphs menu and be sure that Show Graphs is selected if you want graphs shown in the data display window. Next, select from the graph menu options such as Custom Graphs, Histograms, Scatterplots, or Time Series Graph accordingly. In this example, we will first go to Scatterplots and choose Capture X versus Capture Y. This immediately puts the scatterplot graph in the data display window. Capture X versus Capture Y is a scatterplot that gives a visual XY axis representation of the flow cell and shows where each particle was when its picture was taken. The distribution of dots on this scatterplot qualitatively tells the FlowCam operator how evenly the particles stream through the flow cell over the course of the run. Next, we will choose from the histograms option, and from the diameter menu, choose diameter ABD frequency. This graph will display in histogram format how frequently particles of a certain size appear in the sample. This is a common way to view particle size distribution in a sample. We will now demonstrate how to custom organize your data display window. Each field in the data display window can be pulled out as a free-floating window, nested into tabs, or dragged and dropped into specific grid positions of the data display window. Simply click and hold the tab for each field and move the cursor to drag and drop it wherever you want it to be. Once you have a data display layout that you like, you can save it by going to Preferences, Layout, and selecting Save, where you can enter a unique file name for your new layout. For example, we can save this data display layout as FlowCam 8000 Data Display. Once saved, notice how the layout name updates in the configuration status bar. Now that you have your layout open, let's see how data from an open run will be displayed. To see this, go to File, choose Open Data, and from the Select Data window, click on Open Data, choose Runs, and choose a run from your list of saved runs. Click Open, and then click OK. Particle imaging data, including the preferred statistics, graphs, and context details, will be shown in the Data Display window. This completes Lay Out Your Data Display window.